Hello everyone, today we'll talk about the solution to the problem linked list in binary tree. We'll be talking about the straightforward solution, but this problem can be solved using more advanced string-based algorithms, but we won't talk about that too much today. So we have to find in our binary tree a path starting from some node and going downwards that is equivalent to the linked list that we're given. So we can do it as a simple exercise in recursion. And the idea is simple. We want at any point, so let's say that we have this is subpath, then we can either try to match it at the root that we're given, or we can search for the whole path in the left subtree or search for the whole path in the right subtree. If any of those is true, then we have found this path, otherwise this path doesn't exist. And the general edge cases for our recursion to end is if we have run out of elements in our list. That's great, we have found the path. And if there is nothing more in the tree for us, but still there are some elements on the list, well, we have run out of elements in the tree, so it's impossible to find that linked list at this point, so we return false. And of course, this auxiliary function here has those same two checks. And now it wants to check if the value at the root that we're given is the same as the first value in our list. And if it's not, then we return false, otherwise we go to the next value, and if it exists either in the left or in the right subtree, then we can report that we have found the path, otherwise the path doesn't exist. Now the first question to make sure that you understand the solution is, why do we need this auxiliary function? It may be possible to write it without this auxiliary function, but why cannot we just, since we here recurse using the same function, is subpath to the left and to the right, why we cannot use is subpath here in the sense that we can look at if the root value is the same as the head value, and in that case we just go with head next to the left and to the right. So it wouldn't work, and that explains why this auxiliary function is necessary, but try to think about why it wouldn't work. It's not that difficult, but maybe it's a good exercise. And also keep in mind that we have, in Python and in many other languages, a built-in support for, let's say, pruning some unnecessary, well, maybe not pruning, but exiting early when we have found or not found a solution, because both the OR operator and the ANY function are short-circuiting operators. So for instance, for OR, well, OR is true if this or this is true. So if this thing is true, then it will not execute this second branch, because it already knows that the whole OR is true. The same thing here for ANY. If, for instance, force match starting at head and root returns true, it does not execute this is subpath. So this is called short-circuiting, and it's useful because it allows us to not search for the whole space of possibilities, but exit as soon as we know the value of the expression. The same thing applies, of course, to ends and all, because in that case, whenever we see a false value, we don't have to really look for any other things, because we already know the value of the whole expression.